Ladies and gentlemen, thank you very much for taking up the session today. Uh, ladies and gentlemen, we had wonderful sessions so far. I know it's not easy to have continuous sessions, but thank you for having patience and hearing about the presentations. I'd like to welcome Dr. Pramod from Hyderabad, University of Hyderabad, the Business School, uh, School for Management Studies, Hyderabad. Okay, so I would like to introduce Dr. Pramod. His topic is he's talking about applying AI and optimization to real operational challenges. Dr. Pramod is a passionate supply chain scholar and practitioner, currently serving as a professor at the University of Hyderabad. He brings a strong blend of academic rigor and practical insight in supply chain management. Okay. Known for his research driven approach, Dr. Pramod actively engages with industry to translate theory into real world, future ready supply chain practices. Dr. Pramod, over to you, sir.
Thank you, sir. Thank you very much. Good afternoon, sir.
Good afternoon. Thank you. Thank you.
Hope you are able to see my screen, sir.
Yeah, we are able to see the screen. Yeah, thank you. Yeah, please go ahead.
My voice is clear. My voice is
Very
clear,
clear.
sir.
Very clear. Very
Okay,
clear.
sir.
Please.
Thank you. Yeah. So thank you very much, sir, for the opportunity. And it's like very challenging to talk in half an hour of time. So prediction and the optimization. But anyway, we can probably take the questions or whatever queries afterwards. So let me start my presentation and a little bit of hands-on through the a Jupyter notebook in Python. Welcome everyone to this particular session, and quite a lot of stuff I have thought of for you. But before that, let me give a little bit of orientation for you know the in couple of minutes. Sir, my screen is full screen. Now it is full screen, sir.
Yes, yes, yes. You can see that.
I'm just changing my
It's a
slide.
full screen. No, no, the slide is not moving. Okay. Yeah,
Okay,
yeah. Now
slide.
we can see the AI. Yes.
I think there is some problem.
We can
Let me
see
see, sir.
the slide number 2 now.
Okay, sir. Okay, sir. I think there is some issue. I'm just trying to change the slide, sir. Just a moment.
Yeah. Is it not moving? Mhm.
It's not moving, sir, actually. I
Okay.
think you may have to.
No, that can be done also. If Praveen has a slide, he can share in case.
Yeah, I have already shared. I just wanted to change. It's not moving.
Okay. Praveen, if you would like to share the screen with
Yeah,
the
yes, sir. It is from my end.
okay.
Sir, is it
What could
okay?
normally it doesn't
Sir, it
happen?
is, can be shared by me.
It's a
No.
yours screen, Praveen.
Yeah, yes, sir.
Can you move to next slide?
Yes, sir.
Yeah,
Yeah,
it's
it is happening for you, but can
no
I just?
you
Okay, sir. Okay.
you're
It will be a
you're
little
in
inconvenient, actually, sir.
no you are in restream, right? Mhm.
I am in a restream, sir. Uh,
Okay.
Praveen ji, can you make me some co-host or something? That will think, sir. It will
No,
be
you can
little
share
inconvenient.
screen.
Sir,
You no, you
sir,
can
you
share
can
screen
share.
from your side.
You stop sharing your screen, Praveen ji.
Okay, okay, sir.
Please share
Stop.
screen from your side. That's much
Yeah.
better.
Because, sir, I have certain things. I may have to move from
I
screen
know,
to
I know,
screen.
I know, I know. So
Yeah.
you share your full screen.
So just a moment,
Then
sir.
click on the share button. Okay, and then go to the last entire screen. Click on
Sir,
the window.
just a moment, sir. I'm not able to see that part, sir, at all. Screen
No, in
sharing
the
is,
in the bottom you see mic, video, and
sir,
screen share.
it is only mic and the video and nothing else for me, sir.
No, there is
Screen sharing was
no
there.
screen share.
Screen sharing was there. It might have been disabled or
Uh-huh.
something now. Praveenji, please see once. I'm not able to see the screen sharing, sir.
Okay. I don't
Earlier,
know.
I was able to see it.
Okay.
A
Can
couple
you
of
just rejoin just in case?
yeah, yes, sir, yes, sir, yes.
Yeah,
That's the
just
right.
rejoin.
Yeah, yeah,
Don't worry of the time. Yeah,
yeah. Just a moment, sir. Just a moment. Yeah, now I am able to see the screen sharing. Yeah,
yeah. Please click on it.
yeah.
If you click on it, go to the full screen. Click on the window.
So
You
now
see it. Yeah, now we can see it. If
you're able to see it now, sir.
we can see it. Yeah, you can manage your. Yes,
I'm
yes, we
just
can
making
see.
it full screen, sir. I'm making
Yeah,
it
yeah,
full
we can
screen.
see full screen. Yes, we can see it.
Okay, okay. I'm moving
Please go
it.
ahead.
Are you able to see the second slide?
Yeah, yeah, yes, exactly.
Okay. There is some issue. Anyway, so thank you very much, sir, for the opportunity. Without further wasting time, so let us move ahead. So, couple of brief on the developments. There is a lot of hype about the AI, and I wanted to give a few historical perspectives before I actually get into my prediction and the optimization. Time is too short, but I may be a little quick, but people can still afterwards they can watch it and they can probably come back to us if they have any queries. So started in 1919, 1999, 1919, and 54 up to 54, the that was the range when Alan Turing was alive, and there is a test called a
Okay.
Turing that came in the month 1949. And test is basically there's a machine and
Mm.
there is a human, and the questions were passed to the both of them, and it was not known that who is actually receiving the question, right? That is a Turing test,
Mhm.
and 50 more than 50% of the times it was the machine who was responding. So this is one
Mhm.
basis. Of course, the Alan Turing could not survive for a long time. He died at the age of 35.
Mhm.
Now, second big intervention with respect to AI is if 43.
Sir, you are
Are
saying
you,
you are sharing the screen. You are moving the slide.
no, sir. I'm on the first screen
Okay,
only. I'm
okay,
just giving little brief. It is not in the
okay, okay.
screen. It is
No
not in
problem.
the presentation. I'm giving little historical perspective.
No problem.
So Warren McCullough and Walter Pitts in 1943, they basically spoke about the mathematical model of artificial neural network.
Mhm.
Then we had 1953, Leod Shapley, who basically talked about the you can say integrated with some solution, but later it was integrated with the AI for having the explainability layer in terms of the AI solution. So that was the year 1953. Then 3 years later, John McCarthy in the year 1956 coined the term artificial intelligence, and that was in a conference at Dartmouth in US. So that was actually in 1956. Then we had a few more as a term that was probably coined by Arthur Samuel 1959 at IBM. So these are the few of the interventions that have happened with respect to the AI and the related field. Now the big challenge here is in the mathematical in any AI without mathematics or the statistics, there is hardly any kind of progress. So if you see historically, statistics is a kind of a concept started way back 17. You have the operations research basically came up in during the World War II, 1939 to 1945. So if you see the entire perspective, so AI has relatively its base from 1956 onwards, but several interventions have been taken care of prior to that, and we are using actually a lot of concept in the AI and the machine learning to have the speed increased in the process. So that way, as far as people are comfortable with the related stuff, so I don't think really we should be really worried of, because there's a lot of apprehension that AI can take the jobs, right? So that is why I thought I can give you a little bit of perspective. And so these are the few things that have happened with respect to the AI and the machine learning. Probably we can go to the further historical things and look at the different perspectives. So of course that was not in the presentation, so I just wanted to brief all of you. So what is happening, as I told you, that during test, that is the test between the test, I think it happened in 1949. So 1949, then after 5 years, the Alan Turing actually died. So that is what is the perspective behind the AI, and so a lot of interventions have happened, and now with the AI we are probably increasing our speed. But one critical thing that we all need to remember, that the knowledge should not be replaced by the inputs given by AI, right? So in the sense, replacing it, otherwise it will be a robot. So human will be replaced. So that could probably lead to societal unrest and other things. Anyway, so these are the few briefing. So not necessarily with respect to my presentation. So these are the few prediction and the optimization tools that we have from various companies. And of course, SARS company is also giving a lot of insights with the BSC and the ERP related solutions, and hopefully they also may be integrating certain things with the AI. Prominent players in the market who are basically into AI and machine learning based models, and many of the people in this slide are using some of the software, and some are using, of course, open source softwares like Python. And of course, I have a few things to speak about the Python, that I have it at the background. Now, there are a few libraries, those who are acquainted with Python might have understood. Otherwise, you can probably go to other things and look for a few codes. And of course, the Python has and its AI companion. In case your code is not working, so probably you can look for the solution there. But in any case, the human intervention is needed, and you have to thoroughly monitoring it before you can execute. And get your solution right. It's not like one stop solution, you get everything at one go. You may have to keep trying, and because any you're adding constantly codes, and then it may take time, and probably you have to link to other codes again to get the solution. So then little bit of how things are happening with respect to the traditional AI, and the recent thing that we are basically talking about, the agent based modeling, where we talk about the agents. So the agents are basically can be a forecasting agent, can be a data related agent, can be performance related agent. So any agent that you are really putting in your code, that means that you are adding extra layer to your codes, and they are actually working very efficiently to give you the better solution than actually the one shot kind of solution that we are actually receiving at some point in time. Now we are talking about the layer that is actually Shapley additive explanatory. I told you earlier, this was given by Leod Shapley in the year 1953, 3 years before John McCarthy introduced AI. So this talks about actually you are adding more layer to a particular problem, and you are giving a solution which is more explainable to the client, or to the solution itself, right? So what is really happening actually, this is using a kind of a concept called cooperative based game theory, where you are actually trying to find that every player, you might have heard that 2% zero sum game in the game theory, those who are little bit of acquainted with the game theory. And it's not always 2% zero sum game. It may be the cooperative based game theory where everybody contributes to something. So similarly, if you translate this to the statistical or the mathematical angle, you can probably see a typical regression model may have different features, right? So now if you see and find out the solution with respect to the step regression, there you can find that stepwise you are keep adding the variables. Actually the case here in this case, so what it is doing is it is giving a prediction that is actually the best prediction, and then later the features are typically added to the prediction to give you either increased prediction or maybe decreased prediction dependent on the SAP values that are generated by the system, that you have to write the additional code for that. And you can probably check with any AI tool that you are acquainted with. But anyway, it's ending off with again the software engines like maybe Python or something that you have to solution. You may have to check according to your requirement. So I told you earlier that you can have the agent that is basically deciding the business goal, right? Then you have the data agent. You are probably pulling the data, then cleaning the data. Then forecasting agent that is actually training, selecting, and validating the model. Then optimization agent that basically talks about how you can optimize based on the your parameters. Certain times you may have to optimize, right? A little bit of idea I should give you that in the forecasting there are certain times that is a simple exponential smoothing for the prediction, and it doesn't have any trend or the seasonal fluctuation. You can have only the parameter that is alpha. So what is the best alpha for you, right? Those who are acquainted with a little bit of optimization, probably you can minimize the MAPE based on your alpha, right? So this particular alpha, sometimes our students ask who will be giving this particular alpha. So nobody will be giving you as a researcher or as a kind of industrial professional. You may have to keep working on this to get the best forecast. And please remember that every use your forecasting problem will have some error, and those forecasting error you can only minimize, but you cannot really eliminate. If you can eliminate it, probably it's a coincidence, but I don't think it is a really a true solution that you have received, because nobody can really predict the future, whether it is an optimization problem or a prediction problem. So similarly, you have the reporting agent. You can probably give you the dashboard, the summaries, etc. So these are the layers that you can probably keep adding to your solution to get a more refined solution. So now, with the advent of that in the reference section, probably in your leisure time you can keep exploring those things. So then, with respect to the AI, then we are adding few things with respect to the responsibility, how the AI can or the AI code can behave little responsibly. So sharp, this is what already I have told you, and what it does actually incrementally takes into account the variable, and what is the contribution of each of those variables, right? It not necessarily kind of a regression coefficient or some other parameter that you receive, but is actually it may be fluctuating either on the positive side or it may be on the negative side. Maybe you can keep exploring that. There is a website dedicatedly available for Sharp, and it will give you a better explanatory solution for your problem, where you can probably see that no feature is neglected. It has a minimum bias. It is very very transparent in terms of the solution. Then certain times actually in the explanation you may have to have some intervention, right? The human intervention, looking for human intervention, because you cannot leave everything to the AI. Certain times it may give you a pop-up that your intervention, you give your input, then it will again execute the code. That is called the human intervention with respect to the accountability. Then of course you have to factor the privacy and the governance related issues, then safety and the reliability related issues. Then you can say with respect to the inclusiveness, like for an instance, in a typical hospital, a person who is from well-to-do families is coming, and a person from a poor family is coming who has a lot of money or a very rich. That way, it is not inclusive, right? It has a bias, so that has to be controlled in the AI system. Now, how can you actually implement this? You have to define your the principles. Okay, what are the layers that you are actually going to execute? Then it may need to, it to be put in place for proper education and the training of the people who are handling it. Right, as I said, people can use for their speed, not necessarily by replacing their knowledge. And you have to integrate in the users should be protected with their privacy, and human intervention is needed time to time. You cannot completely leave it to the machine, because certain times you cannot factor. Let us say you have 1,000 problems, so every 1,000 problem may not have a typical solution in the AI. So there may be a kind of a solution needed, whether it is generative AI or agentic AI. Certain times the human intervention is basically needed. So then the pop-ups would be there for the human control. Then things will move further. Now, let us talk a little bit of supply. It's a typical, typical supply chain. Is basically from end, it's a kind of end-to-end process. I think Abdul sir might have given you the essence of it. I don't want to take more time on this. So, it's a end-to-end process. The starting with the supplier's a supplier to the customer's customer. And those who are more interested in this area probably can refer to some of the books that I've cited in the references. Most prominently, the Chopra and Mendel, and the other one is Simsi Levy. So both are extremely good books in terms of their concept and the AI. So you can probably think of the AI in the SCM. You can probably think of demand forecasting, and as you know, that forecasting is kind of a lifeblood of the the supply chain, right? So why I'm saying this, because without forecasting, you don't know how many units you are going to produce, right? And you do not know how many people you are going to serve. And having known that no forecasting is correct, then why we are going for the forecast, right? So it will give you some kind of a thrust to move ahead. If you are dealing with the product that are basically made to stock kind of product, then you're called MTO, that is made to order. Then your forecasting may not be that appropriate, but you can still have some kind of a basis for your forecast. So typical aggregate planning problem, that is starting with the sales and operations planning, where a demand forecast is a key. There you are actually talking about again the the linear programming problems, then mixed integer linear programming problems, right? All those kind of stuff you can bring into. You have some objective function, then the can say the constraints. Okay, man, machine, power, money, any other input, they cannot be negative. So you bring that particular layer, and you try to solve it. So there also you can probably bring some kind of demand forecasting, and then we can optimize, because this is the primary step in the aggregate production planning. I think sir must have given something with respect to the ERP in the last 3.5 hours. I could also see some of the things there. So they may be interlinked. Then you can use it for routing optimization, right? There you can use the reinforcement learning. Then you can use when you can integrate with the again optimization based tools there. The supplier communication may be, of course, little bit of generative AI. There you can use natural language based processing tools, risk detection, predictive maintenance. Everything can be a part of predictive analytics, but the core is basically the machine learning. And I don't want to get into too much of machine learning here, because I told you that the machine learning was coined by the Arthur Samuel in the year 1959 at IBM. So what actually it is doing is, rather than explicit for a typical problem, you have a code already, and you pass the data through it to give you the solution, right? No matter what is your data, but the data you may have to define what is your independent variable, what is your dependent variable, and what is that actually is the technique that you are going to use. Then that way it will give you the solution, right? So let me move a little bit of forecasting the techniques. I don't want to get into too much the details of the mathematical expressions. Those who are interested in this area can probably get into this. So this is a simple moving average exercise in day-to-day lives. Okay, there is nobody that is not using what is average, right? So sum of all the values divided by total number of values. That's a basic concept behind any statistical thing. And as you know, that mean is basically mu and sigma is another parameter. These two are the very, very critical parameters in any statistical inferences, right? And statistics is the base, and operations research is the base. So you need to first of all define a forecasting model with respect to the moving average. If you say all these all these vertices are all equal to 1, then the denominator will be translated into n. So then you have the forecast. Now the question comes here, how can you probably get the best forecast? Maybe you can probably give the vertices something, then that vertices can be optimized by using a linear programming problem. And that is simple, that you have the MAP, that MAP can be minimized. Similarly, another algorithm, that there is one parameter called alpha. Then sometimes people ask how to take the best alpha. So you can probably use your heuristic, that is trial and error method, to get the alpha. Otherwise, you can optimize it, optimize your MAP, that is mean absolute percentage error, to get the best of the alpha. Then there is another method called Holt-Winters method. That actually is a little bit of refinement. I think I missed a regression in between. So in between, you can probably keep regression. Regression is basically a method who is basically, many of the world financial, right? So you can say there's a simple logic that you take a big curve and take a small part of it. It's a straight line, right, or a line segment. So majority of the problems can be solved with this, but certain times we may have to take the non-linear or the polynomial based regressions. Then other methods are also available: neural network, right, XGBoost. There are certain lasso regression, ridge regression. There are a lot of techniques available. You can probably experiment with your quality time, right? So spending quality time for understanding all this to change your code and write a better code for that. So Holt-Winters method, actually there is a Holt method. I believe I missed a couple of things here. So Holt-Winters is basically a method that talks about Holt is one mathematician and Winters another mathematician. Both of them have a combined method, and Holt also has a method. So the Holt method basically depends on the regression, and Holt-Winters method also depends on the regression, but there are two different smoothing constant in case of Holt. That is, alpha is a smoothing constant, beta is a smoothing constant. Here actually alpha, beta, gamma, there is the train, and the other one with respect to the signal factor. This is another algorithm that you can probably explore. You need not, if you don't want to understand this, maybe you can take the help of one AI tool to you can simply dump your data in the chat GPT or any other co-pilot, whatever, to get the result. That's not a big deal. But if you want to really understand the little bit of domain, this is how you have to proceed. So there is one critical thing that we statistically we talk about, the seasonal factor. So the seasonal factors can be calculated this way. If you're comfortable, you can calculate. Otherwise, you can take the help of estimation. Now the other one is OLS. There is ordinary least square, which is the background of the linear regression. There is another one called autoregressive integrated moving average method. This is a Box-Jenkins method of 1979, right? So quite a almost after 23 years of AI was coined by like John McCarthy. So yeah, this is actually standard method in the statistics. If you have, no matter what is your trend, what is your seasonal fluctuation, lot of your stock data, lot of your financial related data, lot of your data with this method. A little bit of neural network based model where you have it is not necessarily a statistical model. It is a refinement of you can say the parameters with respect to this kind of solution. And the this is a nature inspired algorithm where we are basically taking into consideration the the method with respect to the neural network. Now the performance measure, this is actually is the measure that is very prominently used in the demand forecasting. You can also use RMAC. There are also other things called AICBAs and so on. So let me take you through taken with respect to the regression. And as you see here, I don't know whether you are able to see the font size is small. I'll be sharing, I think, the presentation that you can see afterwards. So it's a simple method. I'll just show you the data actually for this. The data here is a simple problem in the Chopra and Mendel book. You can probably refer. This is simple, data here that is for 12 months of data available, and this is a salt related product. here. And what is happening here, if I show you the trend, so you can see there is a lot of fluctuation, right? So that means that the solution may not be lying with the linear regression, so or maybe moving average or exponential smoothing. You may have to bring a little bit of more layers into it. So that layer could be with respect to little bit of explanatory layer, where you can see what is happening with respect to the demand fluctuation when it comes to different months. So this data also I'll be sharing with you. So this is what I have done actually, just to have a trial. The entire data set I have given to ChatGPT, but there actually I have just given the data, and I wanted these methods to be executed, right? These methods to be executed. Of course, I didn't execute neural network because the data is very small. And what you are able to see here is basically that that the MAP, which is the mean absolute percentage error, which is just 9.32%. So that means it's a very nice forecast that we have got, right? But in contrast, ARIMA and other methods could not give us any better result, right? So similarly, you can also do with respect to, you can also bring the other layers, where you can probably try with the Shapley, as I told you, for the other course. Now let me talk to you, because time is too short. So it is actually, I'm giving little high level thing to you. You can probably plan afterwards, and you can probably come through Abdul sir or Pravinci for any other queries. I'll be definitely happy to help you. So I have taken just two models in terms of the optimization. One is the capacitated plant location model, and the other one is the aggregated production planning model, right? So just to know few plant locations, and you have the markets, right? So you have you can say the market, it is like n by n or n by m matrix, and you have the demand in all the markets and the potential capacity of each of the plants. Then you have the fixed cost and the variable cost, right? Now, if you want to really frame a typical mixed integer linear programming problem, you can probably divide with respect to the fixed cost, and you can divide with respect to the variable cost. And here actually there is one dichotomous variable integrated with the model. In the model, where you can probably see if you use one, otherwise it is zero. So now you can solve that particular one with respect to the solver, or maybe you can use Python. There is one software called Gurovi. So that there are a lot of softwares available you can probably use. Or if you are interested to get the ready-made solution by dumping it to any other AI tool like ChatGPT, you can probably explore that. So then another problem with respect to, I think I was watching Sir's presentation, so I believe Sir might have factored some of these things in the ERP solutions, where actually you have the chase strategy. That means when demand is going up, you are actually hiring people, and you are assigning extra time to the people, etc. But when demand is decreasing, then what people do ultimately is they basically for their action, the people, they retrench people. That is actually one thing. This is one strategy. So it is a good or bad from the ethics point of view, that we are not talking like AI taking jobs now, maybe some certain cases, but people need to get equipped to learn and to see their speed. Then level operating plan, you are constantly using the employees, the machines, capacity, etc., and you keep producing, no matter what is your inventory and all that, right? Because when you are constantly producing, may lead to the stock out, and when demand is low, then unnecessary inventory will be definitely piling off. And what we need to do in such a case, actually, you can probably use the heuristic method, or maybe you can use the trial and error method, which basically is a optimum. It can be optimum optimization based method, or it can be a simple trial and error based method in the Excel sheet, or maybe in any other AI tool. You can keep exploring these things. So I'll go to the model. So this is a little complex model in terms of the formulation. You can have more layers of constraint in case you have, but there are very minimum number of constraints that I have figured out here. So you can see the workers, number of workers in a planning horizon, then the capacity that basically you are expecting from the production, then the inventory that actually you are holding at the beginning, and what inventory you are planning to hold it at the end, and if you are planning for any stock out that you're actually planning. So please remember, stock outs actually we don't really take it very positively in the business, because it may lead to the customer dissatisfaction and maybe attrition. Then you have the overtime constraint, where you can probably see that how many hours each worker can work So that is a little bit of HR ethics here, because people may be interested to work for more time, but the problem is actually not at the cost of their health, right? So that way, maybe HR can come into the intervention and say that this is what is the time that somebody can work with respect to, right? And inventory, if you want to have a little bit to the next planning horizon or the planning forecast, planning period, that is in the future planning period, then probably you can have a fixed value. And of course, there is all the variables should be non-negative. Now, how the these theories are actually impacting the society. So we can see that what is happening with respect to the the AI agents. Of course, they are actually in terms of their thinking, their behavior. So you have to bring additional layers there. Then maybe interaction of the AI and the human operator, the human oversight may be essential, especially in the healthcare sector. That is very, very essential. Or maybe high precision cases. There you may need to have some human intervention. Then you cannot completely leave it to the AI code operating it. So you may have to have some kind of how it is changing with respect to the time, that also you may have to factor.
Fine.
Then importantly, we have to factor the AI and kind of the this thing, the codes there. So then finally, AI aligning with the human moral and societal values, that also should be integrated. Now, I'll just quickly take you through my codes. So I'll not take much time. So I was given 30 minutes. So um, I think I have more or less taken that. But given the overview, please remember that this, the kind of stuff that I've given in the last 30-35 minutes can be a concept for at least 30 hours. But you need to little work on that and proceed. Any questions or anything that you can probably see? Now let me quickly show you the code. So here I have taken one data set. That particular data set I'll also show you. This is actually from my own research. This is a prediction data set where I have taken from agriculture. I basically do some agricultural related research and do some forecasting and machine learning based models. So there are three different variables here. So these three things, I just want to have the demand as my prediction variable. So supply and the price, they are actually independent variables. So let me take you through the codes quickly. I may not explain each line, so you can probably go through it, and I just try to little increase the size. Just to bear with me for a moment. A little bit of size I'll increase so that you can see it. Yeah.
So,
So now, these are actually the libraries. Then I'm using a model called Sarimax, a little bit of higher order model here. I have shown you in the presentation. Those who are from econometrics, mathematics, statistics background maybe will be able to follow. But what it does is basically it takes into account your time, and it takes into account the exogenous variable. So supply and the price, these are the exogenous variable. I'm basically trying to predict the demand. So I have read the data. The data has I can show you how many records that we have. That also you can read in the code itself. 20 observations in this particular case. So now I'm plotting, and you can see how things are looking like. This is actually the basic descriptive, the minimum, maximum, quartile 1, quartile 2, quartile 3, and so on and so forth. And you can see the kind of the fluctuation. The highest fluctuation that you actually see in case of the demand, irrespective of the fluctuation of supply and the price, are not very, very high, right? Then what is that I'm doing? I'm reading my training data and the testing data, right? So that way, training and testing. And this particular model, as you see, is a Cerimex model that talks about the time frame, where the time is basically going to one period back. Okay, so you can go with 2 or 3 period back. Maybe I'll be sharing the code with you. You can just try 2 2 2 1 2 2, any combination, right? That you can try and see how it is actually happening. And there is also ML code available for auto machine learning, right? that is also there. So in this case, what you see here is the Cymax model that and as you see here, higher order statistics who are a little familiar, maybe knowing that there is a Jack-Vere test that basically talks about the normality. So normality is basically not here. So and the logic is basically for the time series data, you cannot really expect a perfect normality. So homoscedasticity is basically available because it's a two-sided test where your p-value is greater than 0.05, and then you have autocorrelation, partial autocorrelation. Those are the things also you can find out.
Yeah. So great. Is
Now
it
I'm
open
getting into
source?
the prediction. So these are my predictions. Yes, sir. Open source. It's open source, sir. It is by using
Open
Python
source.
code. I'll be sharing that entire, what is that? The code with you, and you can probably share with the participants. So I have predicted, and these are the predictions. As you can see, the data is relatively older because I have taken from Ministry of Statistics and Program Implementation. You can also have the new data there. Anyway, I'm then you can see how perfectly we have generated the prediction, right? But please remember, it may not be the case all the times. So as you can see here, the basically the red color is your forecast, and the most very close to the actual data, right? Then let us see the
Fantastic.
MAP. The forecasting error is very not very low, I can say, but it is reasonable. That is just a 12%. So 12% of you can say error, or translating into 88% of accuracy, is not a very bad forecast as such, I can say. Then what I'm doing is actually I'm bringing a little bit of additional layer to to explain explanatory layer to use SHAP, that is supply additive. I'm just you just have to use a particular library. So everything, those who are into development side, they can probably get into what is happening in the library itself. But many of the people, they may not be interested in this, so you can simply import the libraries. Then you have to define certain things with respect to the background data, with respect to the layers. So you can keep
Fantastic.
running the cells to see what is really happening. So what is that we are going to do here? You can see, yeah, you can see here in this case, this is a very good figure here. As you can see, the price, the red color, price has a lot of red color, which is actually adding value to the. So supply is very stagnant, and it's a real data set actually. You can use your own data set to see how things are really happening. But certain times, if your model is correct and you are going against the normal thinking in the society, then you may have to take a call, because if the data is correct and your output is something which is going against the normal thought process, you may have to be a little careful there, because people may say this is what is happening and you are saying something else. So you should have the guts to face the
Yeah.
people.
That.
So now what happens here is forecasting. There is a baseline forecasting, and this baseline forecasting every year I have done it for 24 months, 24 observations actually. So that is 24 observations means 24 months, you can say. So then the this is actually the supply, and this is actually your price. So every single month it has taken plus minus wherever required to give you the best forecast. And this best forecast, if you take with the SAP values, then you will get the prediction that is actually driven by your whether it is going up, coming down. If it is going up, why it is coming down. If it is going down, why it is coming down, right? That way it has given you more explanatory power.
Mm.
Then what is that you can do? Then this is what is your average value. You can probably recommend this figure to your company, or maybe depending on the forecast that you actually received in this thing, that you can probably recommend. Month wise you can change, provided your board and your committee
Perfect. Perfect. Dr. Pramod, we need
permit you,
to just.
because there are a lot of
Yeah.
humanitarian. Yes, yeah. So then
Yeah. Thank you.
one more, yes, sir. So then we checked with the fairness. So it is the code you have to push, right, with some threshold. It is saying that no fairness violations are detected, so you can proceed with your prediction. Then finally, if you want some kind of uncertainty to be figured into the forecasting, then you can probably use some kind of 95% lower confidence limit and upper confidence limit to get the value. So this is another forecast, but I'll be sharing the
Great, sir. Great.
code with respect to the agentic AI, where sharing maybe you can probably think about it. Now, for another 2-3 minutes,
Yeah,
I'll just talk about, so just spare another 5 minutes, we'll close. Then this is actually with respect to the aggregate production plan. This aggregate production plan I have solved in the solver. Okay, in the solver I have solved it, and I got 4,23,900 is the total cost. And there are a lot of inputs available here that you can also try with any other software that you're familiar with. But now I'll be showing the same thing in the Python, that is to install pulp. So there you are reading it. Then I have given all the kind of inputs that is there in the Excel sheet, and finally I'm getting my solution almost close to my solution that I've received through the solver. You can see exactly I got, I believe, 4,23,900, and these are the month-wise plans. So how many workers that you need and how many you have to hire, you have to retrench. Normally we don't use fire, actually it is a retrenchment. Then the production, how much of production you can probably expect, whether it is needed for an overproduction. Overproduction normally takes the overtime. Overtime is more costlier. You can probably think of with subcontracting as well, but you have to see the standardization related problems. Then how much inventory that you are actually carrying. You can probably bring extra layer there and say that inventory of 2040 is on a higher side. You don't probably need. You can probably control, give additional constraint there. Then you have the stock out. Of course, we said in the algorithm that there is no stock out preferred because it may lead to the
perfect.
penalty. Similarly, is for February, then March, and then April, extending for a year or so, depending on your aggregate production plan problem. Now, a little bit of code that we have done for the sensitivity analysis. Okay, in the operations research or the optimization, we bring little bit of sensitivity. So, if the cost increases by 1 unit, then what happens with respect to the total cost? As you can see here, it was the original algorithm that has given us the solution. And this particular solution I have already shown you in this APP with the solver. I've solved with the solver. If I can show you quickly, I don't want to get into all the codes here or the constraints here. So half a dozen code that or the constraint that you have to write. It's a very simple solution, but people often get confused with the intricacies. But you may have to systematically do that. Then if the cost increases by 1 unit, then what happens with respect to the total cost? You can find for 6 months or maybe for 1 year, right? So this is how you can probably keep continuing with your
Very interesting.
solution. And I delivered, but a little bit more time that I've taken. So I believe it has given you
Yeah,
some
it
insight.
needs.
But please remember that
Yeah,
there is no simple way for learning, no matter how best AI that you are actually using. So now maybe with a food for thought, I can leave you that can you integrate your ARIMA with neural network? If I ask some people, those are a little bit of high standard, you can probably think, okay, what is the logic behind you are taking two different methods and integrating them? Maybe I can give you a high level solution. You can integrate
very interesting.
your data with the ARIMA or SARIMA. You find the error. That error you further take your models. Model and especially people who are, please don't use AI for writing papers, right? Will be definitely rejected. So these are the few things I believe um, has given you some. So I can stop sharing my screen.
Yeah.
I think it is
So
already
thank you, Dr. Pramod.
stopped. I think screen share.
I know. The
So
time required for this high-tech session is a little more, but given the time constraint,
sir,
I really enjoyed and I wanted to go through it. If you share me that, I'll try to read myself thoroughly because we are on
yeah,
the same path anyway. So I will be definitely happy to do that. So thank you, Dr. Pramod.
sir. Actually, sir,
Yeah,
just a moment. I have already shared the presentation, and a few more things I'll be sharing with Pravinji.
yeah,
And if needed, you can probably think of bigger time frame
yeah.
for
We
these
will do that.
solutions.
We will do that.
Yeah,
We
we
will
can
have a
probably
one
think
session
of.
for that.
I just wanted to give a very high level thing to your audience.
Thank
So
you very much.
hopefully there will be some
Thank you.
researchers, some people from industry,
It
so they
gives
can
it gives a
probably.
thought that how to do that
Yes,
this
yes, give a thought, yeah,
sample.
just to give a thought,
Thank,
not necessarily to teach these methods or discuss these
thank you very
methods.
much.
Yeah. So
Thank you,
thank you
sir.
very much,
Thank you
sir,
very
for
much.
the
Thank you.
opportunity.
Thank
Thank
you.
you, Praveen.